Okay. So let me take an example of some numbers. 5. Okay, I think I'll use the text.
Mhm.
Okay, 5 pi 0. Some numbers like 0.533 is repeating. 0.246, where 46 is repeating. Okay, one more fraction I'll take, say 22/7. Okay, now this 5 is a number, positive number, so we can consider it as an integer. 0.53, now here 3 is repeating, so it's actually it is 0.53333. So this can be written in terms of a fraction. Now when it's a fraction, it can be a rational number. Same thing here. Here two numbers are repeating, 46. So it is 0.2464646 repeating. So even this can be written as a ratio of two numbers, two rational numbers. 22/7, both are integers, so this becomes a rational number. But suppose if we can't write a number in terms of the ratio of two numbers, then we call it as an irrational number. Here, this pi, which the answer is 3.14, it goes on. So this pi is an irrational number. More example for irrational numbers are square roots of numbers. This is square root of 2. So this is an irrational number. So basically, irrational number means a number which cannot be written as a ratio of two rational numbers. So this is irrational number. Now, let me take one example to find out a number like this, where a number is repeating. So I create the screen. I'll take one example of, say, 13/75. 13 divided by 75. Okay. Now the procedure, this usual procedure. Okay, so 13 divided by 75. Okay, so let me put some zeros here. Okay, so 75 doesn't go in 13, so it is 0 point. 13 is the remainder. So this 0 will be brought down here, 130. Now 75 into 2 will become 150. So it is more than this 130. So it will go once, 75, 1, 75. So when we subtract, we will get 55. Okay. So next we'll bring down the 0, 550. Okay, now we have 75 and 550. So 75 into maybe say 5 times. If we do 5 times, we will get 25, 35 and 2, 37. It is still a smaller number. Let us try with 7. 75 into 7. So 7 5 is 35, 7 7 is 49, 49, 52. Now this is a number very close to this 550. So let me put this 525 here. So 75 into 7 times will be 525. Okay, so when I subtract this, I'll get 25. Then let us bring the next 0 down. So we get 250. So this 75 into 5 is 375. It's bigger than 250. So if you go one less, so 75 into 4, that will be 300. It's bigger. So 75 into 3. Sorry, this should be 75. So 15, 21, 22. So 225. Now this is a number less than 250. So this will be 225 here. So we get a 3 here, and the remainder is 25. Now next number 0. 0. Now we see that we got 250 here. Again we are getting 250. So again this 225 here and 1 3 here. Now this 3 will be repeating here. So it goes on repeating. So the answer of this is 0.17333, and this 3 repeats. So we can write this as 0.17 and 3 with a bar over it, when telling that it is repeating 0.133. Now this is a rational number. Now how to convert this back to a fraction? Okay, so I'll take example of some examples, and we'll see how this repeating numbers, rationals, can be converted back. Let me take an example of 0.3, where 3 is repeating, and this is nothing but 0.333, and it goes on. Now how to convert this to a fraction? So since there is a single digit here, let us multiply. Let me take this as, say, x. Let me multiply this with 10. When I multiply this with 10, I will get 3.3 recurring. Okay, there's nothing but 3.33. It goes on. Now let me subtract x from this 10x. So x is nothing but 0.3 recurring. So 0.333 goes on. When we subtract, we will get here 9x is equal to here 3, and all these recurring decimals will cancel, and we'll get a 3. So x is nothing but 3 by 9, or nothing but 1 by 3. So we have converted one fraction where, one decimal where one variable is repeating into a fraction. So this is the principle how we can convert it. Same thing if we have a number with 2 repeating variables, say for example 0.24 and 24, both are repeating. Then the same principle, but we have to multiply with 100. Suppose I take this as
2 decimals.
Yes, 2 decimals. So this will be 10x
or 100x
is equal to 24.2424. It goes on.
Isn't it 100x?
Oh, sorry. This should be 100x.
Yeah.
This should be 100x.
Yeah.
So let us subtract one x from this. So this will be 0.2424, and it repeats. So when we subtract, we will get 99x is equal to, these repeating variables will cancel, and we will get 24 here. So we have expressed this repeating variable into a fraction, 24 by 99. So this principle will work for any number of this repeating variables.
Yeah, thank you, Rolvin. It was great class, and I really appreciate it. Thanks for your time.
Yeah, thank you. Okay, thank you very much.
Thank you. Bye.
Bye.